Hello and welcome to a Decepticon and Autobot walk into a bar. I'm Joe Gray. I'll be your presenter for this session. Before we get into the actual presentation, I would like to thank you for taking time out of your day to spend with me as I share something that I've been working on and that I am passionate about. Welcome to a Decepticon and Autobot walk into a bar, a Python tool for enhanced OPSEC. I'm Joe Gray. A little bit about me. I'm a senior OSINT specialist at Complex by Day. I also provide OSINT training as the OSINTian periodically, typically 3 to 5 times per month. I have some experience with Python scripting. I would not consider myself an expert by any stretch of the imagination. I am really good at piecing code together to make it work. It's not pretty, it's not always the most efficient, but eventually it does work. I'm incredibly interested in data science. I'm most interested in specifically the aspects of machine learning and natural language processing. I see a lot of use cases for that in the worlds of open source intelligence and social engineering, both from an offensive and a defensive perspective. I frequently compete in the Tracelabs Missing Person CTF or OSINT Search Party. I'm a member of the Password Inspection Agency. We won the competition this year as part of DEF CON in August. I'm very passionate about OSINT and OPSEC. I also have advisory volunteer roles with Operation Safe Escape and the National Child Protection Task Force in the United States. A few things that I'm not. I am not a programmer by trade, nor am I efficient, or I would even venture to say good at it. I'm not a mathematician or a data scientist. Honestly, at the college level, I've taken statistics and pre-calculus. And honestly, I want to end human trafficking. I want to end domestic violence, but I am not an expert in those fields. So before we get started, I want to go over a few definitions just to set a level playing field so that we all understand terms that I'll be tossing around. So we have OSINT, which is open source intelligence. Basically, that's information coming from overt sources. That is using things on the public internet, public records, social media. People post cat videos and pictures of their food all the time, and people like me are just lying in wait to capitalize off of that. Operation security, that's the act or activities associated with obscuring your operations, whether that be your information presence or that you are traveling. It could also include disinformation and deception to make that data unreliable. Decepticon is a term I've been using for a few years when talking about OPSEC through disinformation and deception. Machine learning is the study of the math and the algorithms associated with improving automation. It takes into account previous decisions and outcomes to influence the algorithm. Data science is an amalgam of several disciplines in math that will use processes, programs, structures, and algorithms to gain insight from the data. I like to think of it as it's a means of taking a very large data set and trying to find a pattern that is not necessarily visible to the human eye. Artificial intelligence, that's the study of intelligence, looking to see what the outcome or cognitive results are. It seeks to mimic natural intelligence, which would be the intelligence shown by humans or animals. And then finally, we have graphic processing unit. Basically, that's a specialized system to accelerate the processing of images or video. It's very commonly used within machine learning to speed up processing. So the problem is, one of the leading ways that adversaries find their way into the lives of their victims is social media. So when we think about that, we can always think of it as adversaries. So an adversary could be some malicious person trying to seek financial gain, could be someone nefarious seeking to harm the victim, Could be abusers, traffickers, nation states, political opponents, or it could just be adversaries of opportunity. Very recently, we've seen within the OSINT community, someone went looking for their crush for 10 years, made a connection with them, and then even after making the connection, continued the onslaught by trying to reset their Instagram password that gave them an email address, and then trying to reset the password in Gmail for that to find out what kind of phone they used. So when we talk about the victims in this, it could be a public figure such as a politician or an executive. It could be a victim of domestic violence or trafficking. But most commonly, it's the person who has poor or misguided OPSEC. I have a friend who said that he was totally secure on the internet because he used a free VPN and a specific DNS provider. And we had a good conversation about if you're not paying for the product, you are the product. And I helped him better understand DNS in this case. So it was misguided OPSEC. He totally could have been read as an open book, but hopefully now it's a little bit harder. So let's dissect some possible advice. These are pieces of advice that I've heard people say. Well, if you've got an abuser, just block them. Well, that's possible until they create a fake account. And honestly, if you just abandon the account, well, you don't have to use social media. It could provide a cue to the adversary to look for another account. Additionally, let's just be real, some people have to use social media for work. That could be because they're in sales or marketing, or it could be because they work as an OSINT specialist. Honestly, some victims are not aware that they even have an adversary until it's too late. And then the final piece is, honestly, why should someone have to live in that fear, and why can they not maintain the agency to use social media? Why should someone else's actions prevent them from using something that should not have any bearing on the other person? As we dissect this a little bit more, I got into this a little bit earlier. If the victim blocks the abuser can use fake accounts. Depending on the access and privacy controls, it could be friends of friends. The adversary could potentially report the victim's alternative accounts as being fake and prompt the victim to have to use a driver's license or another form of identification to prove that they are who they say they are, and in that case the account gets burned. If the person uses the same password everywhere, which is more common than I would like to admit, they could be reset or guessed, and then honestly companies can still be exploited. From the perspective of an OSINT investigator, I'll be honest, I'm more skeptical of a subject that doesn't have any social media presence than those with some. And that's dependent upon gender, age range, location, all of that kind of stuff. But at the same time, oftentimes, people have social media. If we're talking about someone in their 70s or 80s or someone under the age of 5, okay, yeah, I'll buy that they don't have social media. But if we're dealing with someone in the United States, you're supposed to be 13 to create a social media account. So if we're dealing with someone ages 13 to say 65, I anticipate at least a Facebook, maybe an Instagram, maybe a LinkedIn. And honestly, I've stated this before, why not have the autonomy and agency over what is posted with minimal effort? So with this, I created Decepticon, and right there are the links to the GitHub repos if you want to take a look at it. Basically, they are the exact same thing. The second one is just a shorter version if you want to jot it down. So the code itself, it's written in Python. I've got 2 versions. Only one is available publicly right now. It uses TensorFlow and Keras. I think it's pronounced Keras. It could be Keras. I could be entirely wrong. I have been before, and I probably will be again. As it is written now, I'm using the NVIDIA port of TensorFlow version 2.2. The other version is using PyTorch, but it's not discussed in this presentation. I use pandas to organize the data and move it from one module to another, as well as writing it to a comma-separated value. Within this, I use a long short-term memory model to actually generate the text, and that is enabled via Keras. So what is a long short-term memory model? Well, an LSTM is a type of a recurrent neural network. Well, cool. What's a recurrent neural network? That's a type of neural network that's going to take into account past decisions and influence the outcome. They can actually remember previous things learned, assuming that you save them and you manage them. Unlike a regular or traditional neural network, it's not of a fixed vector size, which makes it really good for things like text, speech, and images. So an LSTM is a type of recurrent neural network that will learn ordered dependencies and perform sequence prediction. That's very useful in any language, whether it be English, Ukrainian, Spanish, French, whatever. There are certain words that follow another word. There are certain sequences. We have our traditional phrases that we use that are language specific. And with this, it can actually take any of that into account in pretty much whichever language and do that with the prediction and dependency analysis. So how does it work? We use a set of Twitter API keys. I only use the free API for this, and the Python-Twitter package. This is for authentication and to actually pull down the tweets and get the fields that we want out. Originally, and as the code is in GitHub, it will read the owner of the API keys tweets and tweet in their likeness. I've got a fork called SOC that you actually can create a list of accounts you want to read from, and it will use that to generate. And that's what it's currently doing to get a little bit more diversity. I've got 6 accounts that it follows right now. 4 are men, 2 are women. 4 are in the same geographic region and 2 are outliers. But all 6 accounts tweet fairly regularly, and that improves the posting interval, which we'll discuss in a moment, and it also improves the diversity in the language, which makes it a little bit trickier to predict, but at the same time, it's not just me plugging my training or retweeting this or retweeting that, because the code specifically ignores replies and retweets right now. The tweets are tokenized, which basically means I separate everything into words, and we could do this by sentences. I'm actually planning on rewriting it to do so as sentences, and then we add it to the corpus. A corpus is a term used in natural language processing to describe a group of words, a bag of words, if you will. So we collect some statistic data on the tweets, so things like a standard deviation and things along those lines, but we also determine the post interval. And the way that we do that is actually using a standard deviation of epoch times. So it looks at all the epoch times, which is just an integer, and it performs that statistic analysis, and it says the standard deviation of these tweets is 4 hours and 19 minutes. So it'll post approximately 4 hours and 19 minutes apart, and it recalculates it with each iteration as well. So in the generate module, we're going to come up with vector sizes and sequences. We measure the number of unique patterns in the corpus. And then we set up the files associated with the model so the tool can learn from it. That's using H5 and JSON. Next, we move into the trainer module so that we can get our pseudo-random seed and begin the tweet generation, which actually occurs in the tweet creator module. That's going to execute the model as we've defined it. The model will be a long short-term memory model of a varying size. I've had good success with some data sets at 224, others at 160. Finally, we do the logic check, which is where we ensure the text is short enough to be able to tweet, so less than 280 characters. In this case, I don't measure 280 characters, I measure 20 words. And it removes links, known characters, any patterns that I discover that it's picking up on. Like at one point, it was just going on these tirades of apostrophe comma repeatedly 6 or 7 times, and then it would spit out a word and do it again. And I've written the logic check to where it cuts all of that out. It also removes hashtags and mentions as well, and the only hashtags and mentions that you actually see from Decepticon now are the ones that I append at the end for the purpose of demonstration. So for this, it would be hashtag Decepticon at NoNameCon.org, and then it tweets, and then it goes into a waiting period. Now let's do the demonstration. Now let's work through a Decepticon demo. Connected to Twitter and receiving the tweets, tokenizing, so now we see it's created the TensorFlow device, the first epoch of 7. So each epoch is intended to improve the accuracy of the data in the LSTM. We'll verify that the epoch kicks off, and then I'll scroll up and we can take a look at some of the other stuff that spits out on the screen before this. And there the epoch has kicked off. So during this epoch, I'll scroll up. So right here we see the stats for the tweets. There's the lexical diversity. That's the measurement of the number of words used in comparison to the number of words total. Standard deviations, and then the tweets occur at this interval apart. I've tweaked the code so that we won't have to wait that long in between tweets. Here we have the bag of hashtags, so these are the hashtags used from the various accounts. The links, if we want to take a look at those as well, and here's who they actually mention. Total number of characters, vocabulary, creating the statistic model, and then we continue through as it goes through the epochs. While it's doing this, I'm going to shift it over for the remaining 45 seconds and go through this. This is just showing the statistics on everything. We see the GPU is near maxed out. A lot going through all the processors. Memory usage is pretty high as well. We can look more at the GPUs, at the CPUs, Memory, here we see I've got extra swap enabled from this in addition to a swap file. We can control things like the fan, and we can determine which power model we're in. And then we can look at the info here. I'm going to shift back over momentarily. Okay, we're finishing up that epoch. We're going to see the GPU just completely die off for a moment. There it goes. And it's already into the next epoch. We will go through a total of 7 of these, and then it will work through tweeting. Now we are coming up on the end of the final epoch. So as this goes through, it will then generate the actual, it will convert the model into the tweet and then post it, and then start the waiting period to start the process over again. So just waiting for it to finish. So, how to fly aircraft. We want dog. One of the most toxic, mental health scaring, self-esteem killing ideas I internalized in the past is the notion Decepticon. So it's going to wait for over an hour and run again. I'm going to make some modifications and we'll see it work a little bit faster. And we see that it's sleeping for 58 seconds. This is, of course, off a modification that ran 2 epochs. Shifting over very briefly to look at the dashboard, notice memory is a little high because the script is running in memory, but there's nothing going on with the GPU. Now it's going again. We'll see everything ramp up pretty shortly, so we're about to enter the first epoch. We can watch for it and see when it starts here. And there it goes. Let's take a look at the code. So first we're looking at the imports file as opposed to adding 32 lines of code to the actual Decepticon bot. I created another file to import that has all the imports, so we only have to do one singular import in the main script. So here we're just importing OS, path, system, regular expression, time, random JSON, pandas, NumPy, TensorFlow, Keras, H5Py, NL Toolkit, NL Toolkit corpus, and then Twitter. Here's the requirements.txt file to be able to install everything that you need. And then here's where the rubber meets the road. So here we start out. Thanks to Adrian, Goldar, Dreadjack, Bill, that guy, NoNameCon, and JFerg for the help. So from Decepticon imports, import all, encoded in UTF-8. There's the login, but let's start here at the very beginning. We pull the stop words. They're not used in this current version, but basically that's words like the, and basically filler words. What I've been abusing you with throughout this entire presentation, and my apologies for that. Next, we find out what the working directory is and look for the existence of a files directory. If it's not there, we make it. If it is there, we keep going. We define the stop words in English, but that can be changed to any language. We set the physical device for the GPU. That's going to allow us to take advantage of the CUDA cores. We'll test to make sure that that works. And then next we define API. That's how we connect to Twitter. We define the model as sequential, and then results, that's the API call itself. So then we come up to the top. We start with login. So we create the data frame in this one, and we define users. These are the users that I took a look at with their consent. So this looks for the CSV file. And then we define tweets, times, lexical diversity, and user. Then next we move into tokenization. If the file exists, then we just import it and put it into the data frame that way. Lexical diversity, there's the measurement for it, which quite literally is a length of the set, the string of the text compared to the length of the text. So in tokenization, we define the bag of hash, bag of mentions, and bag of links. They'll be used in later revisions. And then basically we get everything within the timeline. And then we do a for loop to be able to get the text. We pull the hashtags, the mentions, and the links out using the regexes and the baggers. So it just appends it to that. It saves it. It stores it in memory. Nothing is done with it yet. I have some plans for it. Then we move to the hopper. So for every user, we pull down the tweets. And we do the same thing here. And then it goes into the sorter. In the sorter, that's where we do the tokenization. So basically, we iterate across the data frame. We've stopped referencing direct information directly related to the tweet, and we're referencing data that's within the data frames. We use the tokenizer and fit on text for a string. I had used the enter variable to have that as a list so that we could just pull everything from the data frame into a list. And then it treats that as a string. And then for token in that, it adds it to the bag of words, saves it as a comma separated value, runs the stats, and does the frequency analysis, and then it does generate. For stats, we're doing the stats for the tweets, so lexical diversity, the mean lexical diversity, the standard deviation of lexical diversity. So this gives us an idea of how many words we use and relative to those words, how much we deviate from them. We establish the post interval, and then we move into frequency analysis. So that's not used in this particular version, but I've went ahead and left it coded in for right now. Then we get into generate. So we define characters being the bag of words. We convert those to numbers right here. And then from there, we have our vocabulary length. And then I've set sequence length at 500. X and Y data is for the shape and vector of the model. For there, we come up with a pseudo-random number associated with that. And this is where we get our X and Y pseudo-random seeds from. We determine how many patterns we could have based on the X data, and then from there we move into pre-modeling and then the trainer. So pre-modeling, at this rate we create the statistic model, and at that we save it as an H5Py file. We look for a JSON file as well. If we have that, then we'll import it as the model. But we also continue to save the H5. We look to monitor loss, and the verbose 1 just means that we get to read it. We're using a categorical cross entropy model with RMS prop optimizer. This is part of that A/B testing I was talking about a little bit earlier. and then at the end we write to a file, and all of this only exists if that JSON file exists. If it doesn't, then it moves straight into modeling. We define a 160-bit long short-term memory model. We've got the X and Y shape, and we want to look at the sequences. With dropout, this is another thing that I did A/B testing with. I tried to go up to 0.8, which would be 80%. That wasn't very effective. I tried dropping down to 40%. It works very well at 2 rounds of 60 and 140. So that's the reason it's set up that way. We have activation set to softmax, and then RMS prop. That's another number that I toyed with. I tried adding zeros in between the decimal and the 1. It didn't work out too well. And then we work through. And then right here, when we see with TF device and GPU, that tells us that we're actually executing the GPU to do it. We've defined 7 epochs, batch size of 8. If you set the batch size or the LSTM size too big, you will the script will not execute because it will exceed a buffer. And we continue through the trainer. This is going to create our random seed and then go through the pattern. And at this point, this is where it's going to convert the integers back to characters. This is where we get our words from. So it just works through all of that. And then I defined cleanup. That's just removing all the erroneous stuff that I did not want it to tweet, such as mentions, hashtags, links, any of that. The iterations of several apostrophes and commas, anything along those lines. And then I append hashtag DECEPTICON and mention NoNameCon in it. And then we go into repeater, and this is where we have our waiting interval. Right here we see sleeping interval. This is where it was waiting for about an hour, but normally it's post interval, and then I've just got it set to subtract a random interval between 1 and 1 and 8 minutes out of that. And then it sleeps, and then from there it goes into subsequent. Subsequent takes it all the way up to tokenization. And that's pretty much all of the code with it. There is another file called tkeys, and that's just where you put your 4 Twitter API keys. And then from there, once you input that, then everything will work. So about the project, I started around December 2019. There were many hurdles, some shiny objects, of course, some delays. I'd written some things in Python like WikiLeaker and the associated Recon NG module, a few other things, but I'm still not a Python developer. I'd been reading about natural language processing and machine learning and how to implement those disciplines in Python, and I had been doing some work with Operation Safe Escape. Around March, the project stalled, and I was a guest for CSEC East, which is Brian Brake's security group. One of the other presenters was talking about the Jetson platform for AI and machine learning, and I was interested, so I went on Amazon and bought it. I ported the code over and resumed developing the tool. And honestly, it's because the VM I was using, it wasn't weak, but it wasn't efficient. It was using 3 cores, 8 gigs of RAM, had the Radeon GPU. It was on a 2017 MacBook Pro, so it wasn't anything to particularly scoff at, but it was not optimized for what it is that I was trying to do. So this is the NVIDIA Jetson platform with the T300 board attached to it. We used the USB bridge to connect the two. By using the T300 board, we're able to have a hard drive attached to it. Right now I have about a terabyte connected to it. On the right we see just the regular Jetson board that you can run by yourself as well. You don't get any additional RAM or processing power out of the T300 board, but you can expand your storage which in turn you can use swap as well. There is an onboard micro SD card on the Jetson, which is where the hard drive, or I'm sorry, the operating system is stored. So you don't want to max that out if you don't have to. So this is basically what mine looks like. I don't have the antennas or the camera, but everything else is identical. The specifications on it is it has a 64-bit ARM processor with 4 gigs of DDR4. It's got the Tegra support and the 128 CUDA core Maxwell GPU. I just saw recently where NVIDIA is releasing a new graphics card, fairly cheap compared to some of their others that has 9,000 CUDA cores. I'm looking for an excuse to build a computer. So why the platform? It's external to my regular host, so if I need to travel with it, I don't have to stop research. And it has that enhanced GPU with the CUDA cores to make the analysis go faster. It was recommended by a friend during that presentation, and I definitely wanted to give it a shot. So, as with everything, there are lessons learned. So what did I learn? Data science is not a walk in the park, especially if you lack that heavy math background. PyTorch is oftentimes faster than TensorFlow, but from what I've dealt with in terms of the data set I've presented it's not as reliable. If you're testing it on your regular account, make sure you've tweeted some things of substance as of late and frequently. If you don't want to make other modifications to the code, you probably don't want to start tweeting to your regular account. You want to use an account that is not followed by many people, because people will send you DMs telling you that it is annoying, spammy, all the above, and rightfully so, but it's definitely interesting. So one thing I did, my post interval when I initially started was 12 days. So to try to influence that, I broke up several songs and poems and tweeted them in chunks of 280 characters so that I would have another data set. And basically what I picked was All Star and Never Gonna Give You Up from song perspectives. I mean, it's a little borderline trolly, but that's okay. And then poems, I used the Jabberwocky, the Raven, Still I Rise, Wasteland, and We Wear the Mask. I felt that last one was probably most appropriate during COVID, but nevertheless. But honestly, there's a lot of A/B testing. You will try something, it'll work or it won't work, and you hypothesize it. You try it, it doesn't work. Okay, why didn't it work? What could I do differently? And then you move on. The other limitation that comes with this is having around 200 tweets at maximum of 280 characters is a very small data set for an LSTM. You're not going to get laser precision with this solely on the premise of that particular reason, because it's a very small data set. So right now, the code is written to use GPUs with CUDA cores. If you do it on a VM or a server, it's going to be very time consuming. As you recall from the demo, the epochs were fairly quick, but when I ran it in the virtual machine, they were in the ballpark of like 54 minutes per epoch. So if you just wiped an account or you just set it up, you're going to get something posted for it to work off of, or you're going to have to use the SOC version of the code to be able to pull from someone else's account and impersonate them. At this time, I'll open it up for any questions. And while questions are coming in, if you'd like to contact me, here's my contact information. I've also got the Jetson Amazon idea list if you want to play with one of these yourself. And there are the GitHub repos again. My upcoming speaking engagements, I will be presenting next week at the Australia OSINT Symposium. That is on a different topic, so definitely tune in for that. I'll be presenting Decepticon at ZeefCon as well. And then Sector, Hacker Halted, B-Sides Orlando, and Hackfest. I'll be teaching OSINT courses at both B-Sides Boston and Hackfest. B-Sides Boston is a one-day course. Hackfest is a two-day course. They will cover business and people OSINT in addition to some OPSEC with a capture the flag element in it as well. The missing persons OSINT course that I teach in preparation for Trace Labs competition, I'm offering it on these dates. These are all in Eastern time. I apologize for not running a more European friendly time, but I've got a pretty cramped schedule right now. So if you want 15% off and you want to take the training, use TraceLabs15 as your coupon code. I'm also developing an introduction to social engineering and a technical social engineering course, in addition to Linux for social engineering and OSINT, as well as a Python scripting, APIs, and automation course for OSINT, as well as I'm in the process of rewriting both my business OSINT and my OPSEC course to take them from a 4-hour version to a 6-hour version. If you want to stay up to date on it, you can follow me on social media or sign up to the mailing list. I try not to spam people, but it kind of happens. These are not the complete dates for Hacker Halted. I failed to update this slide. So in this regard for Hacker Halted, if you just go to hackerhalted.com, you can use that code for free admission. Some of the speakers include Jenny Radcliffe, Chris Kubeka, Alyssa Miller, Malware Jake, Chris Roberts, myself, and more. And that's the end of the presentation.
Okay, Joe. Thank you for your speech. It was really great, really great. I'm impressed so much. And let's switch to our Q&A session. And the first question is really funny. So probably it's related to the name of your speech. Which Transformer part is your favorite one?
I have to go with Bumblebee.
Okay, and probably you don't know, but the previous speech was about bot protection and detection of bots. So did your Decepticon bot face any issues with different anti-bot detection systems and mechanism?
There was no detections from any automated systems. I did receive quite a few DMs from people asking me to move it to another account so it would stop spamming their timeline.
Mm-hmm.
But from the purpose of bot detection, I'm actually planning on using some of the same code used within Decepticon to actually try to enable bot detection using natural language processing.
Okay, thank you for your answer. And also you mentioned that Decepticon covers different use case scenarios, including public figures and different executives. Usually, government love to ask to use such tools. Did you already get some requests from politicians or executives to help somebody with Decepticon tool?
Not yet. And from, when we think about it for politicians, at least in the United States, we have that clear line between here's the official account and here is the personal account. In terms of the Decepticon bot, I would never push for it to be used on an actual official account, like using the president in the United States as an example. I would never be cool with it being used for @POTUS, but a personal account, to be able to have that sense of agency and privacy as the human being as opposed to the elected leader, that's where it would go into play.
Yep, that's great. Our next question, could you please share your opinion about the biggest challenges of NLP?
Honestly, finding the patterns and slang. That's one of the big ones. For the purpose of Decepticon, one of the biggest challenges faced was the size of the data set, just because of Twitter API limitations and Twitter's 280 character maximum. You can have far more effective NLP using things like long short term memory models if you have a larger text. So, for example, one of the assignments in a lot of the Python based NLP books and even machine learning books typically has you import the text file of a popular book and then use the NLP um, mechanism to rewrite the book. And then, of course, because it's the human element, there is a certain level of unpredictability that cannot be captured via mathematical equation with that. So, if you say hello to me, I may respond as hi, hello, ahoy, how you doing, howdy. You can't predict all of those things. So when you insert the human element, that makes the prediction of that harder. Seeing as with a lot of the stuff that Decepticon's working with NLP is written, that makes it a little bit easier. But again, the size of the data set's probably the biggest challenge.
Okay, got it. Thanks. And actually, what's the difference between AI, ML, and NLP, from your opinion?
NLP is a discipline underneath those two. Uh, NLP seeks to understand the dynamics of the human language, not body language, of course. That's a different NLP in natural and neurolinguistic programming. But in terms of natural language processing, it uses AI and machine learning techniques to gain an understanding and comprehension of words for the purpose of attribution or um, prediction. AI ultimately is, by and large, kind of just a marketing buzzword to a degree, to be honest. Vendors have kind of ruined the phrase AI just like they did with cybersecurity. But basically, um, you're seeking to replicate some form of natural intelligence, like that of a human or an animal. And then machine learning basically is attempting to, that's the algorithms that's meant to enable the other two. So they're all kind of related, but definitely a bit different in the regard of how they are actually implemented and what their limitations are.
Yep, and let's go to the next question. So you have a really huge experience doing different OSINT and other related tools, but people used to say about their success a lot. Could you please share your biggest fail during OSINT or OSINT training?
Well, my biggest fail during OSINT training as an instructor typically is related to um, a technique not working from one class to the other, or it could also be from me selecting a missing person, because in my training, that's what I typically do. I pick a missing person and we actively, as a class, look for the person. I might pick a person and um, and it not be someone that we can find a whole lot about, or we may run down the wrong rabbit hole. Professionally via OSINT, I would say my biggest failure probably just has to do with a specific case I was working on that I got sucked down into the wrong rabbit hole and ended up eating up all of the time. So I wasn't really able to find anything on the actual subject that I was looking at.
Yeah, I think
I mean,
it's
I fail every day, honestly. Um, my failures they don't define me, but they certainly help shape who I am. Um, I'm a practitioner of Brazilian Jiu-Jitsu, and in the words of Helio Gracie, you either win or you learn. So um, if I don't experience a win, I take it on the chin and find a way to be able to build something out of it that enables me to grow.
Yeah,
If I'm
sure.
not failing, I'm not trying.
Yeah, and actually you can't win without losing before, so it's like normal process.
Yeah. And to be honest, if you knew how many times I ran Decepticon unsuccessfully um, through the process of doing the code analysis and getting everything running, debugging, because I don't come from a heavy coding background. I mean, the amount of failures in that are far more substantial than the successes.
Okay, thank you. And what non-technical sources of information would you recommend for social engineering and OSINT? Some books, podcasts?
Books. Oh, thank you for the segue to that. My book will be released on October 13th via No Starch Press. It's called Practical Social Engineering. It is available for pre-order on Amazon right now. In addition to that, on the non-technical side, I would read Influence the Psychology of Persuasion by Dr. Robert Cialdini to understand the social engineering aspect of it. For OSINT, honestly, reading anything from Michael Basil is definitely worth taking a look at. His whole series of books. And then honestly, with OSINT, there are some ground truths that you can read, but a lot of it has to do with performance. So what I tend to try to do is find people that I kind of know. I know a little bit about, but I don't know everything about, and I get their consent, and I go off and see what I can find about them, and I share with them what I find and how to get it removed. So practice can certainly practice does make perfect until Facebook changes their API the next time, more or less, is probably the universal truth within OSINT. But just staying on top of things, there's a treasure trove of data on Medium for it. If you go to my website, theoscension.com, I have a wiki that has links to resources, blogs, podcasts as well. OSINT Curious is a good OSINT webcast and podcast. And then Michael Basil has his podcast as well that works, that's exclusively OSINT as well.
You know what? Nastya just posted a link to your book on Amazon, so probably you might get few new customers.
Hey,
few new
sounds good.
pre-orders.
And I'll say this now: if anyone does get the book, and if it is safe to travel next year, I fully intend on coming up with some groundbreaking research to submit to NoNameCon next year. I will sign it in person. If it's not safe next year, then I will. If anyone reaches out, I will send them a digital signature.
Yeah, thanks a lot. And oh, you get quite a big amount of questions. Wow. So, are there any plans to employ BERT for bot engineering?
Right now, I don't have any further plans with Decepticon aside from I plan on advancing it at some point. I've got a few other projects that I'm working on right now, mostly in the training space. I am trying to work on a new tool right now, doing some email OSINT. So I will probably end up revisiting Decepticon later this year after obviously after the book is out, the publicity is done for that. I'm in the process of creating a Udemy course on OSINT, and as well as rewriting my existing OSINT courses. So I've kind of put my development stuff on the back burner right now, but I will be looking at other things whenever I go to make the revisions to Decepticon. Because as I created Decepticon, I purposely avoided looking at things like OpenAI and other similar tools and techniques solely on the premise of I didn't want to either subconsciously recreate whatever it is that they were doing, nor did I want to inject any artificial inefficiencies or workarounds, because I decided to know how they did it, and I was trying to consciously avoid every single way that they've done it.
Okay, and we have like a few questions more, but we are a little bit out of time, so I'll ask the last question. Guys, if you have more questions, you can reach join
If you want to
Twitter.
continue, yeah, I was going to say, if NoNameCon wants to moderate them on Twitter, I can handle them there, and if not, they can either tweet at me or hit me via DM. Either way.
Okay, so the last question here. One of our attendees asked, said, thank you for the report, and he missed the point. Could you please repeat what was the primary reason behind Decepticon implementation?
Basically, I was just studying Python-based machine learning and a natural language processing book, and I got tired of doing their examples. They kind of felt a little boring to me. So I started cooking everything up. I was like, can I generate stuff for this? And then I work with Operation Safe Escape in the United States, which is a nonprofit that helps domestic violence victims get out and stay out. There's an OSINT element to that, and some social media consulting that goes alongside it. And basically, this is a means to an end where someone can abandon their social media account and walk away without providing too many clues to the abuser. And then, as a byproduct, as I was working towards the later stages of it from an OSINT perspective, I realized that this could also be used to manage SOC accounts. So there's a fork in the code on GitHub that addresses that, but I do want to further refine that a little bit more as well.
Okay, thank you. And I will use my power of moderator to ask one more question from NoNameCon crew. You had a tree on your logos. What does it mean?
That is the Yggdrasil, which is the Viking symbol of wisdom and knowledge. That's the logo that I use for the Ascension.
Great, thank you. So really, it was a pleasure to have you here. Thank you for your great speech and all your answers. We are looking forward to see you next year, probably offline in Kyiv. So thank you again.
Thanks for having me, and I look forward to it. Everybody should be safe.